Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 8. Today we're going to learn about hierarchical clustering in machine learning. Let's move the topic. Hierarchical clustering is used to group similar data points together based on their similarities, creating hierarchy or tree-like structure. The key idea is to begin with each data point has its own separate cluster and then progressively match or split them based on the similarities. Okay. So, an explanation of this topic is hierarchical clustering is a method used to group the similar data points together. The key characteristics of this technique is that is create a hierarchical tree hierarchy or a tree structural cluster. Okay, so the core idea to the start treating each other individually data points has its own separate cluster from the algorithm. It has its own data points and separations. Okay, so the algorithm works in on the one or two way. So most of the way we have agglomerative bottom up and divisive top down. Okay, these two methods we use most of it. So, in simple terms, let's understand this with the help of an example. So, let's do the example. So, what we have example? Imagine you have a four fruits, okay, with different weight. An apple, 100 grams, a banana, 120 grams, a cherry, 50 grams, and a grape, 30 grams. Here, hierarchical clustering starts by treating each fruit as its own group, okay? Here, apple is one group, and banana is one group, cherry is one group, and grape is similarly different group. So, treating the groups here. So we can see that uh, it then matches the closest group based on the weight. Okay. So what we'll do here, we have apple and banana, both similar type fruits. Okay. So here cherries and grapes look like similarly, right? It will bit 80 to 50% similarly, right? Small and shape round. Okay. So it similarly group these cherries and grapes one side and apple and banana one side. And after that, merging those two, they divide the separate cluster will be formed. So first the cherries and grapes are grouped together because they are the lightest, right? So next the apple and the banana are grouped together to find the similarity. So like there are the different types of clusters. So like they form each and individual cluster will form here. So we can say hierarchical clustering is an unsupervised machine learning algorithm that group data into a tree or nested clusters, right? Okay. So here we can see here we have different types of fruits. Okay, we have papaya, pineapple, strawberry, cherries, grapes, and whatnot. So it divides the each and individual cluster separately. Okay, so it divides a separate cluster. It forms a cluster, and each cluster divides the different groups. Okay, by leveling. So two types of clustering we have: partitional algorithm and hierarchical algorithm. Okay. So first one, partitional algorithm construct various partitions and they evaluate them by some criteria. Okay. So hierarchical algorithm creates an hierarchical decomposition of the set of the object using some uh, gradations. Okay, focus on the class. Okay, bottom up or top down, or it is a directly top down. So hierarchical, like if we have like we have we can say we have some example here of from the Simpsons characters. So Simpsons cartoon characters. So we have the grannies and the mother and the child and the aunt. So it divides the group. So mother and child were equal to one cluster, and grandmother from they both are come from one genes, and the aunt come from the cousin group. So like the divides, like the tree structure will be created by the hierarchical method. So partition nothing but they all comes into the one group, like family into one group and other outers in one group, like that. So how to hierarchical clusters? So the number of the dendrogram with an n leaf. Okay, it has some basic calculation. Bottom up algorithm started with each item in this in its own cluster. Find the best pair to match into a new cluster. Repeat until all clusters are focused together. Okay. So we already discussed. We have two types of clustering. Okay, we have algorithm and diversity, right? So we have level one, level two, level three, like that. So here we can see the A, B, C. So further we take the parent like BC. After that it come in the AC, then we get the ABC. After we have DE, it combines the like it has a different types of levels. It according to the data, it groups it the leveling. Okay, so like that, dividing two groups and merging those into the final group. So that hierarchical tree structure will be formed. So what it does, so in algorithm it does the top up, bottom up. So in division, it's come from upside. Okay, so it grows from ABC, it commences the BC, and over the overall final output, we have ABC as a group. So, okay, level 3. From division, it comes from the level 3, like if DEFG. So it divides DE and FG separate, and after that separation. Okay. So we begin with the distance matrix, with constant the distance between the every pair of the object in the database. So like the database will be divided. So we can see the 0 to 8. So dot 8 and 0. So we have a 8D like that. It's a simple checkbox calculations. So we can easily identify what's the mean of this table. Okay. We can easily identify the table matrix. So here we can say that bottom-up algorithm. So starting with an each item in its own cluster, find the best pair to match into a new cluster. Repeat until all the clusters are focused together. So considering all the possibilities, so choose the best. So we have the two grannies and mother and granny, and we have the mother and granny too, and aunt and mother and the grannies, and like we have granny and child. So let's see how the group will be divided. So it's considering all the possible match, so it taking the possible matches from the choosing the group. So after that, it dividing, choosing all the possible match, like the choosing the best, like EFC. First, it two is separated. After that, it matched the both of those because the granny is common. Like that, they merge equal to. They create a family-based tree structure, structured based a tree. We consider all the items in it. So finally, we have the one output. Okay, so your grannies are sisters by one family. So after that, his daughter and her daughter and her aunt. So they all comes into the one tree structure family. The data will be divided. So now, what is dendrogram? So hierarchical algorithm. So we can see here what is dendrogram. So dendrogram is like a family tree for a cluster. Okay, it shows how individual data points or group of the data match together. The bottom shows each data point has its own group, and as you move up, similarly groups are combined. The lower with the match points, the more similar the groups are. It helps to see how things are grouped step by step. So we can see that a dendrogram is a visualization tool, and that looks like a family tree of our clusters. Okay, so it is a key component of the hierarchical clustering, especially the algorithmic bottom-up type. So here the breakdown of the future structure. It is a tree-like diagram. The very bottom of the diagram, each individual data point represent has their own separate group. Okay, so we have some purposes. The dendrogram helps to visualize how the things grouped step by step by cutting the dendrogram in a certain height. You can determine the clusters for a given level of similarities. So we can say we already discussed it. A dendrogram is a tree that shows how the cluster are merged step by step. We cut the dendrogram at a certain height for the final cluster, right? So in the above image of the left side, there are a five types of labeled PQ or SQ, PQ or ST, okay, that represent the individual data points, that being the cluster, okay. So on the right side of the dendrogram, which shows the how those points grouped into the step by step. So we can see the data will divide into in a structured manner by using dendrogram. So here we conclude it. Okay, let's come to the conclusion point. At the bottom of the dendrogram, the point of the P, Q, R, S, and T are well separated, right? Here we can say separated. So as you move up, the closest point are merged into a single group. So closest point will a single group. The lines connected, the point shows how they are progressively merged based on similarities. In the height at the which or the connected shows how the similar the points or each others. It's shorter the length or more than similar to they are. Okay. So workflow for the hierarchical argumentative clustering. So we have the sometimes start with an individual point. Each data point is its own cluster. For example, if you have five data points, you start with the five clusters. Each constraint is just on one data point. So center the one data point. Calculate the distance between the clusters. Second point. So calculating the distance between every pair of the clusters initially, since each cluster has one point. This is the distance between the two data points. Okay. So match the closest clusters. Identify the two clusters with the smallest distance and then merge them into a single cluster. Okay. Update distance matrix. After merging, you now one less cluster. You can say recalculate the distance between a new cluster and the remaining clusters. Okay. Repeat step 3 and 4. The keep merging the closest cluster and updating the distance matrix until you have only one of the cluster left. Okay. Create a dendrogram. As the progress continues, you can visualize the merging of the clusters using a tree-like diagram called a dendrogram. It shows like a hierarchy of the cluster or merger. So, like the steps in algorithmic forms, like it follows the step by step, like dividing the merging the closest clusters after the forming a new cluster. From those, it merging a closest cluster, like it forms the step by step. After it concludes, it group the all the clusters. So hierarchical divisive clustering. So workflow of the hierarchical divisive clustering is start with a data point is a one cluster in one cluster. Okay, treat the entire data set as a single large cluster. Okay, so split the clusters, divide the clusters into a two smaller clusters. The division typically done by finding the two most similar dead points. Sorry, dissimilar points in the cluster. Okay, it uses this then separate the data into a two parts. So repeat the process for each of the new cluster. Repeat the splitting process again. So choose the cluster with the most dissimilar point and split it into two similar clusters. Okay. Then the final stop is stop when each data point is in its own clusters. Continue this process until every point is its own cluster or stopping the conditional such as the predefined number of the clusters in with the group. So like it comes the backward, okay? So it deals with directly data. Okay. Hierarchical. First one deals with data point and it groups the combine of the cluster, okay? It deals the cluster and divides into the data points. So we have the distance matched metrics in hierarchical clustering. So we have minimum distance, group average, minimum distance, and maximum distance and votes method. So like the formulas we use for them. So minimum distance or distance between the closest element of the cluster to find, and maximum distance between the element in the clusters, and average of the distance of all the pairs. Combination cluster increases with the cluster variation into smallest degree. So objective is to minimize the total within the cluster variances. Okay. So we have the again the compressor mean max. See, we can see the in this individuality what we have how many clusters we have 1, 2, 3, 4, 5. So we have approximately we have only two clusters in the both. But after forming, we have the one cluster, two cluster in the one, two. We have max four clusters here. So it divides the individuality. So group average clusters are three, and the word method like we have the in group like cluster into the cluster like okay one whole cluster in it we have second cluster, third cluster, fourth cluster, and five clusters we have like that. So applications of hierarchical clustering it mostly used in portfolio construction and optimizations and sectors and industry analysis and the paid trading strategies. It used marketing structure understanding and dynamic asset allocations and algorithmic trading, and we have behavioral and financial analysis. Though most of the cases, hierarchical clustering will be used. So I hope you guys all are understand about this topic. And my final conclusion is to so this is a useful clustering. We can use in most of the examples. Okay. So I hope you guys understand. Thank you.